Okay, so I'm going to go through with you how to do a chi-square test. I'm going to use this sheet, which is in your lab book, in Lab Unit 15, in this edition of the lab manual. And as you can see, it's blank, and I'll fill this in, and that will show you how to do a chi-square test. I'm not going to do the chi-square test with your data, with the numbers that you collected. Instead, I'm going to use the data from a previous semester to illustrate how to do the chi-square test, but I want you to analyze your data with a chi-square test. Okay, so let's go ahead then. So first, phenotypes of the F2 plants. So the phenotypes are tall and dwarf. There are two phenotypes. Now, let's write in the number of tall and dwarf F2 seedlings that we counted. Again, with data from a previous semester, there were 71 tall seedlings and 26 dwarf F2s. All right, that makes a class total of, I should be able to add these up, but I'm not going to. Google, hey Google, what is 71 plus 26?
The answer is 97.
Thank goodness for Google. I could never have done that in my head. All right, so let's move on to the chi-square table now. Tall in this column and dwarf in this one. All right, so now we're going to write in our number of observed plants. And of course, for tall, that would be 71. We observed 71 plants. And for dwarf, we observed 26. Now we need to get our expected number. Okay, now for that, we are going to calculate an expected number based on a 3-to-1 ratio. The reason why we're using a 3-to-1 ratio is because we want to test to see if our observed is different or no different to our expected value. In other words, are our data different to or no different to what we would expect had the plants followed a Mendelian mechanism of inheritance? Because if they did follow a Mendelian mechanism of inheritance, in the F2 generation, we would have gotten a 3-to-1 ratio, in this case, of tall to dwarf. So that's why we're using the 3-to-1 ratio, because we're testing a goodness of fit to a Mendelian mechanism of inheritance. So let me show you how to calculate the number of tall plants that you would have gotten and the number of dwarf plants you would have gotten if, with 97 plants, you had a 3-to-1 ratio of tall to dwarf. So I'll do that calculation over here. So we've got a total of 97 plants. Let me just get rid of that. Total of 97 plants. Now, for a total of 97, we need to know how many tall and how many dwarf would we have if we had a 3-to-1 ratio. So there's a couple of different ways mathematically you can do this. I'll show you a quick one. Because we're dealing with the 3-to-1, I'm going to add the 3 and the 1, and that's going to give me 4. I'm going to take the 97 and I'm going to divide it by 4. 97 divided by 4 equals, and that gives us 24.25. All right, so that gives us our 1 in the 3-to-1 ratio. So now I'm going to take 24.25 and I'm going to multiply it by 3, and that's going to give us 72.75. This one here I could multiply by 1, and of course that gives us 24.25. Okay, so there's our 1 in the 3-to-1, and there's our 3 in the 3-to-1. Now I'm going to double check to make sure we've done our math correct. This number plus this number, of course, should equal 97, so I'm going to double check that. 72.75 plus 24.25. And it does equal 97, so I know our math is correct. All right, so our expected value then for the number of tall would be 72.75, and for dwarf 24.25. All right, so let me just recap. These are our observed results. These are our expected results that we calculated based on a 3-to-1 ratio. We're using the 3-to-1 ratio because we want to figure out if our observed number is different or no different to what we would get if it followed a Mendelian mechanism of inheritance. If it followed a Mendelian mechanism of inheritance, we would expect to get a 3-to-1 ratio of tall to dwarf. So we're seeing if our results are different or no different to a 3-to-1 ratio. Okay, so I'll carry on with the mathematics of calculating the chi-square test. This next one is the deviation, which is simply the observed minus the expected. Our observed value is 71 minus 72.75, and that's going to equal negative 1.75. Okay, and over here we've got our observed, which is 26 minus 24.25, and that in fact equals 1.75. Okay, I could do the math, but there you can do it, and that's what you'll get. So now we've got to take the deviation, which is this number, and square it. All right, so negative 1.75 multiplied by negative 1.75. I've already got negative 1.75 in there, multiplied by negative 1.75, and that gives us, so negative 1.75 multiplied by negative 1.75 equals 3.06. Now I'm just going to round to 2 decimal places. And the reason why we square it at this point is actually to get a positive number. So now we're going to take the deviation and square that, 1.75 multiplied by 1.75, and that equals 3.06. Again, you can do that in your calculator, but that's what you get. All right, so now in our next row, this is the deviation squared divided by the expected. So our deviation squared is 3.06. Let's divide it by our expected value, which is 72.75. So let's do that. 3.06 divided by 72.75, and that gives us 0.04. Now I'm just going to round it to 2 decimal places. I could take it to more, but I don't have a lot of room here, so I'm going to leave it there. All right, so now we've got our deviation. I'm going to divide that by our expected and see what I get. And I've got, so I'm going to round that to 0.13. Okay? All right, so this down here is chi-square. In fact, it should really be written like this. It's kind of an X with those curly bits there. It's the symbol for chi, and there's squared. All right, so our chi-square value equals, and there's something missing from this, I just noticed. There should be a sum of sign just there. All right, is the sum of our d squareds divided by e's. So our chi-square value is the sum of this and this. And that equals, let's see, shall I use a calculator or do it in my head? Absolutely not going to use a calculator. So 3 plus 4 is 7. All right, 1 plus 0 is 1. There you go. All right, so that is our chi-square value. Ta-da! All right, so we're not finished there. We've got to see what this chi-square value means, and then I'll move to the next part of the lab manual, looking up this chi-square value to see if this is a significant value or a non-significant value. If this is a significant chi-square value, it tells us that these are significantly different to each other. In other words, the difference between these cannot be accounted for by chance alone, so there must be a biological cause of the difference. If this is a non-significant chi-square value, it means that the difference between these is caused purely by chance alone. So, in effect, these are no different to each other. And if they're no different to each other, then height in brassica plants follows a Mendelian mechanism of inheritance, because our observed results are approximately a 3-to-1 ratio, which is what you would expect if they followed a Mendelian mechanism of inheritance. All right, so let's move on to the next part.